Our problem statement is, bicycles nowadays are lack of safety features, especially for elderly, and their safety is at risk while cycling. This statement is supported by the fact from the United States of America's news, where bicycle accident among older riders has increased significantly over the years. There is also a study that says, among all cyclists, elderly cyclists suffer the most head injuries and fatalities. And despite these reservations, biking remains a popular and thrilling pastime for senior citizens. Thus, we come up with a solution for this problem, which is Smart Bike Car. Smart Bike Car is a bicycle that can help elderly take care of their safety on the road and reduce the risk of accidents with special features. Smart Bike Car has the features of DC motor, accident detection system, voice control LED, and speedometer that function to help elderly beware of their safety on the road. Our project's aim is to provide a vehicle with special safety features for elderly and reduce the risk of unwanted accidents. Elderly's heirs and community will be impacted from this project. Elderly will have a vehicle that can care for their safety on the road, and this will lessen their heirs' worriness. Besides, the possibility and percentage of elderly's bicycle accident can be reduced. This comply with our project's theme, which is SDG 11, Sustainable Cities and Communities. Our community, especially elderly as targeted users, will benefit from this project as their safety will be cared more.
Overall workflow flowchart. To start, we first define the objectives and problem statements of the project. Then, we do some breakdown study and generate a proposal from it. Next, we list out the components, estimate the budget, purchase the components, and test their functionality. After that, we design the circuits for its functionality that we decided to put, install and explore tools required, and build the prototype of the project. We then write the coding used for the project and run some simulations. We also improve the prototype build, collect and measure data from the prototype, and test simulation. Lastly, we will write the final report for this project and finalize the build prototype. Speedometer flowchart. First, we make wheel revolution by riding the bicycle. Then, the magnetic contact switch sensor, or also called as reed switch, which the sensor is attached at the spokes of the wheel and the magnet is attached at the front of the wheel to detect the wheel revolution. Arduino then determines the speed of the bicycle. The bicycle speed depends on how much time is spent for the magnet and sensor to be in contact with each other when the bicycle is moving. Lastly, the speed will be displayed on the LCD as we have written in the coding.
For voice control lamp functionality, flowchart start with creating interface at Adafruit to control light. Next, connect IFTTT with Google Assistant and Adafruit by using same ID in Adafruit. IFTTT will interpret the message and send it to the Adafruit dashboard as comment to the feed. Next, connect the circuit by connecting end of LED to D7 in Node MCU and cathode of LED to ground. Then put the key ID of Adafruit as well as change ID and password of Wi-Fi in the coding. Coding needs to be verified and upload in the Node MCU. Finally, this functionality can be tested by giving command to Google Assistant. For example, turn on LED, and LED will turn on, and vice versa. If the LED does not function accordingly, the process needs to be checked again and redo.
Accident tracking flowchart. To start, we first create an applet at IFTTT using the if statement, which is if an accident is detected, an email containing the accident information is sent to the emergency contact. Then we connect the circuitry for the accident tracking system. Next, we write and upload the coding at Arduino IDE. After that, we simulate an accident to test its functionality. We then check whether the accident alert is received through email. If the alert is not received, then we need to restart the process from connecting the circuitry, upload the coding, and simulate an accident until the accident alert email is received. Tools used for speedometer are jumper wires, which we use the male-to-male and male-to-female types, Arduino Uno, a 9V battery, a 16x2 LCD, power supply module, a 10 kΩ potentiometer, magnetic contact switch sensor, 1 kΩ and 220 ohm resistors, breadboard, soldering tools, and Arduino IDE.
Tools for voice control lamp are LED, Node MCU, battery holder, battery, wire, perf board, soldering tools, Google Assistant, IFTTT and Adafruit.io.
Tools used for accident tracking system are non-MCU, MPU6050, which is an accelerometer and gyrometer, u-blox Neo 6M GPS module, a breadboard, jumper wires, soldering tools, and software used are If This Then That, Arduino IDE, and Google Maps.
Turn on LED.
We innovate bicycle lamp using IoT, where it uses cloud platform
Okay, I will turn on.
IFTTT and Adafruit.io that
Turn
also
off
connect with
LED.
Google Assistant using smartphone.
Okay, I will turn off.
Accident tracking system on the bicycle will send the accident location consists of longitude and latitude to the respective areas through email whenever Adelaide encounter with accident. With this system, action can be taken quickly and fatal injuries can be prevented. Speed while cycling can be monitored using speedometer. This is to avoid Adelaide from cycling too fast, as cycling too fast is dangerous. In conclusion, Smart Biker has many special functionalities like voice control lamp, speedometer, and accident detection system that only use phone. From the problem occur, we come up with the voice control lamp. Lamp is important to allow cyclists see at night and prevent crashing. Smart Biker use voice recognition to switch on and off the lamp. This system only use LED, resistor, ESP32 module, and human voice. Originality and uniqueness of functionality of this system are it use Google Assistant with Adafruit.io to control an LED with ESP32. The benefit of Adafruit.io is making project internet connected and connect project to various web services. Adafruit.io allows the user to set trigger for a particular action and it responds. It uses IFTTT to access Google Assistant and to control LED by voice command. We use the IFTTT service to configure the trigger for our project. This system is newly established and is not similar with any other system on the internet, as there is no bicycle with voice control lamp in the market.
Backside camera function as dash camera, which is very useful. With backside camera, elderly with back or neck problem does not need to turn around to monitor what's behind. When connected to a phone, the backside camera can function to display the backside of the bicycle, take pictures and also record the backside view using an application called USB_camera. This feature is very beneficial, especially if accident happens, so that we will have proof of accident for police report purposes and more.
Speedometer is used to monitor and maintain a safe pace for cyclists. Smart Biker uses LCD to display the bicycle speed. This system uses Arduino Uno, 9V battery, resistors, and potentiometer. The specialties of this functionality are: it uses magnetic contact switch sensor to determine the velocity of the bicycle. It also uses power supply module together with battery to power up Arduino Uno, LCD, and magnetic contact switch sensor. Accident tracking system. Accident tracking is crucial to prevent fatal injuries or worse, death. Smart Biker uses Internet of Things (IoT) to send the alert and the location of the accident occurred. This system uses Node MCU, MPU6050, and GPS module. Speciality of this functionality is it uses IFTTT to send the email containing the alert with the location of the accident to the emergency email contact.
For cost of effectiveness, the original budget for Smart Biker is RM460.99, but the actual cost for Smart Biker that had been used was RM445.79. Our cost is effective as we save 3.3% from the actual budget. Thus, Smart Biker is worth the budget as we can put elderly safety first.
Commercialization potential. Targeted markets are the elderly, their heirs, and also motorcycle or bicycle shops, as this project is mainly focused on the elderly's safety. Potential collaborators or investors are the government, vehicle or motorcycle companies, and elderly society. By collaborating with them, we can promote a safe and healthy lifestyle for people, especially the elderly. We would like to sell the Smart Buy car at motorcycle or bicycle shops, online website, and old folks home or nursing home. We believe that these places can sell this bicycle well. We would also like to market this project by using the method of online advertising using search engine optimization (SEO) and social media, advertisement on television or radio, and also on the newspaper to let people know more about our project.